The next example we're going to look at is dealing with an airplane. So let's go ahead and read through this and then we'll sketch it out and see what we can do to solve it. So it says an airplane has an airspeed of 500 kilometers per hour, bearing north 35 degrees east. The wind velocity is 60 kilometers per hour in the direction of north 30 degrees west, and we want to know what is the ground speed of the plane and what is its direction. Okay, there's a lot of different pieces going on in this one, so definitely I want to start by sketching it out. Okay, so we're going to have our airplane. Oops. Okay, now think about your directions here. So it says the airplane is going in a direction of north 45 degrees east. Now what that basically means is if this is our east right here, okay, north 45 degrees east means basically halfway between our north and our east. Okay, so this would be a 45-degree angle right here. Okay. All right, and that was traveling at 500 kilometers per hour. So my hypotenuse is 500. Okay. All right. I'm going to think about my little right triangle here. Okay, so that's my plane. All right, now it says the wind velocity is 60 kilometers per hour. So the wind velocity is going to be adding to the plane velocity. So if we're thinking of adding vectors, we're going to use our tip to tail method in order to add our vectors together. So starting at the tip of our plane vector, I'm going to add the wind vector. Now it says this is going in the direction of north 30 degrees west. So again, just kind of thinking about my compass directions here for a second. Okay, so north 30 degrees west. So saying we're rotating 30 degrees west of north. So we're going this direction. Okay, all right, so that is our wind. I'm going to go ahead and call that, well, I'll label that hypotenuse as 60. Okay. All right. And then if we just go ahead and think about labeling out our little right triangle right here. Okay. So this was a 30-degree angle, which would make this a 60-degree angle. And of course, these are both right angles right here. Okay. Now what we're trying to find is this resultant vector. Okay, this is what we're looking for right here. What is this resultant vector? What is the ground speed? Now this would give us the ground velocity, which once we have velocity, it's pretty easy to find the speed. Okay. Okay, so now I'm going to go ahead and label some of this stuff out. So I'm going to start with my plane. I'm going to label out my components. I'm going to call the horizontal component x1. I'm going to call the vertical component y1. Right, and then similarly with my wind, I'm going to call the horizontal component x2. Now with this, I want to be a little bit careful. Notice that the wind is blowing to the left. So since it's going to the left, this x2 is actually going to be negative. And then I'm going to call my vertical component y2. So think about directions when you're labeling these out. Right and up are positive, left and down are negative. Okay. Okay, so now let's go ahead and figure out our components. So let's start with the wind. Okay. All right, so if we want to find our x2, I'm just going to use my 60-degree angle because that's the angle from the horizontal. It's a little bit easier to think about. So that would be using cosine. So we'd have x2 is equal to our hypotenuse of 60 times the cosine of 60 degrees. But cosine of 60 is 1/2 times 60 will give us 30. Okay. And then y2 that is the opposite side of the 60, so that would be using sine. So we would have 60 sine of 60 degrees. Sine of 60 degrees is root 3 over 2. So multiplying that by 60, we would have 30 root 3. Okay, so putting that together for the wind, we'll call that vector W. We would have negative 30I plus 30 root 3j as our wind vector. Okay. All right, now let's deal with the plane. So x1 is adjacent to the 45 degrees. Remember, we have a hypotenuse of 500. So x1 would be equal to 500 cosine of 45 degrees. Cosine of 45 is root 2 over 2 times the 500 would give us 250 root 2. All right, y1 is opposite the 45 degrees. So we'd have 500 sine of 45 degrees, which would also come out to 250 times the square root of 2. All right, so for our plane then, the velocity would be 250 root 2I plus 250 root 2j. Okay, so we found the vectors for our wind velocity and our plane velocity. Okay, now the combination of these will give us the velocity relative to the ground. So we want to combine these together to get our ground velocity. We have V plus W, so add the two together. Right, so we'd have 250 root 2I plus 250 root 2j, and then minus 30I plus 30 root 3j. Right, combining our like terms, we have 250 root 2 minus 30 in the I direction, plus 250 root 2 plus 30 root 3 in the j direction. Now, if you want to at this point, you can plug these into your calculator and get some decimal approximations for them. I just don't want to have to deal with carrying all those decimal places along personally, so I'm just going to keep them exact. Okay. Okay, so that is the velocity vector for the velocity of the plane relative to the ground. Now, if you go back up to the original question, though, it asks us, what is the ground speed? Okay, what is the ground speed of the plane? So in order to find the speed, speed is a scalar, which means we want to find the magnitude of this vector. So the speed is just going to be the magnitude of this velocity vector. Okay, so magnitude of a vector is just Pythagorean theorem. So we're going to have the square root of our I component squared plus our j component squared. All right, and if we plug that into the calculator, we are going to get an overall speed of 518.78 kilometers per hour. So that is our speed. Okay. Now the other thing it asked us in the original question, though, was what is its direction? So not only do we want to find the ground speed of this plane, but we want to find the compass direction as well. So if we think about this, let me go ahead and just copy this down. Oops. Can you get a hold of it? There it is. Okay. Okay, so there was our velocity vector for our plane here. Okay, so I'm going to go ahead and just draw this out, break it down into its components. Okay, so this was our velocity of the ground. So we found over here that the horizontal component of this vector was 250 root 2 minus 30. 250 root 2 minus 30. And the vertical component of this vector was 250 root 2 plus 30 root 3. Okay. All right, so what we are trying to find is our direction. So if we can find our angle theta in here, we'll be off to a good start. Now that's not quite what we want though. That's not going to quite be our final answer because we want to measure our angle from north. Right? If you think about these, we had north 45 degrees east, north 30 degrees west. So what we really want to know is, let me just get rid of this right here. What is this angle in here relative to north? So we're going to start by finding theta, and then from there we can find that angle alpha. Okay. All right, so since we know the opposite and the adjacent sides, we can use our tangent function. So we'd have tangent of theta is equal to 250 root 2 plus 30 root 3 all over the quantity 250 root 2 minus 30. Okay. Plugging that into our calculator, taking the inverse tangent, we would come out with 51.59 degrees. Okay. Now again, that's the angle theta inside our triangle. We want to know this angle alpha relative to north. So alpha, which we would just subtract the 51.59 from 90 degrees, would come out with 38.59 degrees. So our overall compass direction would be north, 58.59 degrees, sorry, 58.59 degrees east.